Hey you guys, this is Mr. Sal. I'm gone for today, but take a moment to start on the bell work. If you guys haven't grabbed the pink sheet yet, do so now. And I'll be back on Tuesday. I just in some meetings today, so you guys do your best on this. Make sure you listen to the video. I expect you guys to know this stuff because, you just have to do the assignment. And we'll also expect you guys to know this stuff on the test. So you got to have this down pat. The main idea is that you guys understand by the end of the lesson what is a proportional relationship, at least in, I guess, tables and graphs, okay, which we're going to look at. So we'll get started on this, and then we'll go over it. How many almonds in a new container? Just take a minute and see if you can, just think about it, look at it, kind of compare that thing. That's a quarter cup right there, by the way. Just think about how many almonds would fit into that if it hadn't been opened already, okay? Which means those ones in the quarter cup would have been in the container. So yeah, lots of good estimates from you guys. Let's see what it actually is. Well, this one, if you look at the nutrition facts on it, it says a quarter cup servings per container, it's about 40. So it comes out to around 1,120. We didn't actually take all these out and count them because 1,000 is a big number. I can determine when situations are proportional. Take a minute to copy that down. That's a good 3 minutes right there. Let's go over these. Miss Carson plans to order pizza for class. She's saying 4 pizzas will be enough for 10 peoples. So she needs to order enough pizza for the 40 people though. So how many pizzas should she order? This becomes a proportional problem as it turns out, which is why this whole unit is called proportions, so that we can set them up and solve them, which we already know how to solve them if we can just set it up. So just remember that when you set these up, and especially for word problems like this, we can label these as rates, right? Now we're comparing pizzas to peoples, and it doesn't matter which one is which in terms of numerators and denominators on this, okay? For me, though, I'm going to put the peoples in the numerator as people, and then I'm going to put pizzas in the denominator, okay? And yeah, I'm not going to write those all out because I'm that lazy. And so for the other fractions, we should have peoples in the numerator, pizzas in the denominator, okay? So those need to be consistent. You could do pizzas and peoples switched or reciprocated, but it's still not going to make a difference. The answers will still be the same. So now that I know where the labels go, I see that there's this first relationship that they gave us. 4 pizzas will feed 10 people. So that's 10 peoples, 4 pizzas. And then it says, well, how many pizzas? So we don't know how many pizzas. So I use X for 40 peoples. Okay, now this becomes a proportion that we can solve. And I can see that 40 is a multiple of 10, right? You'd say, well, 10 times 4 is 40. So we can do the same thing to the denominator, multiply 4 by 4, and that's how many pizzas she would need. 4 times 4 is 16 pizzas. So how many pizzas will she need? And now I'll write the actual answer out of 16 pizzas here. 16 pizzas. So that's how many she would need to order for 40 peoples. Now next up we got some really large grande pizzas. Now, I'm going to be using proportions, though, even though, like you said, there are different ways to solve these, and that would be good. But, since we are on the proportions unit, I'm going to stick with my proportions on this. So this one, it says, Miss Carson thinks that 4 pizzas will be enough for 16 peoples. So again, we're comparing peoples to pizzas. And just to show you guys it still works, I'm going to reverse it and put people in the denominator and pizzas in the numerator. This time, okay, but you get to choose. Doesn't matter where you put them, the answer will still be the same. That's just for this one. Ms. Carson shows that 4 pizzas will feed 16 people this time, so 4 pizzas for 16 peoples. And then how many pizzas will she need to order for 40 peoples, right? So we got 40 there, and then the pizzas is the unknown. I'll just leave it blank instead of using that variable on that one. Now, there's something else we can see on this one. Remember, there's sideways relationships like we used in number 1, but there's also these upwards relationships. Like to make 16 a 4, you'd say, you know what, I know I'd have to divide that by 4. 16 divided by 4 is 4. So we can do the same thing with 40 down here. We can say, you know what, I'm going to divide it by 4, and then I know that's how many pizzas I would need. 10 pizzas from old Grande's pizza parlor. So yeah, I'll write this on the side as well. So 10 pizzas right here. Now if you're using fish method or cross multiplication, you should still get the same answer though. I like that idea of simplifying that, right? So yeah, like you say, 8 peoples for 2 pizzas, and you could even take that one step further, right? You could say, well, 4 peoples for 1 pizza, and that would be your unit rate, which is what we talked about last time. So yeah, that would be perfect if you guys did it that way. It's still using proportions and solving proportions. It's just shown in a different way. That's very good. Finally, number 3, at Broadway Pizza, 4 small pizzas are enough for 5 peoples. At this rate, how many peoples will 6 pizzas feed? So once again, we go to the proportion, which we love so much. And move this up a little bit. Yep, still a proportion. So we got 2 fractions that are equal. And I'm going to keep the peoples in the numerator. I'll go back to that. And then pizzas in the denominator, so we know the difference. And then we know where to put these numbers. So on this one it says, let's see, 4 small pizzas enough for 5 peoples. So 5 people there and 4 pizzas. And then we want to know how many people 6 pizzas will feed. Now you could go to the unit rate. You'll get a decimal value on that, and that's okay. In fact, I think we get a decimal on this one. Doesn't matter, okay? So for this one though, since it's not really a very clear scale factor on this one, whether we divide or multiply for that matter, I'm going to go straight into fish method because I like fish method. I like it a lot. Well, that means we need 4 values because there's always 4 values in a proportion with 2 fractions like this, and it's always multiply, then divide, and then it equals. It's going to equal x in this case. That's the number of peoples, and then we draw the fish. Okay, well, start with your x, you go down, that's the first number you get to is 6, and you're going to cross it back up here to the 5, swing it back down to the 4, see how the fish is kind of forming there, and then we ended where we started, which is always, should always be the letter, at x. So I can type this into my calculator, right? So 6 times 5 divided by 4, it gives me a fraction as 15 halves, and that'd be fine if you label that as pizzas. But you could also say, well, 7.5 pizzas, okay? So, I'll stick with decimal on this one, 7.5 pizzas. Oh, that's peoples. Oh, okay. So we weren't solving for pizzas on this. It will feed, the 6 pizzas will feed 7.5 peoples. I'll change that. Now, yeah, you guys may be wondering, well, how do you get a half person? It's just an estimation on that one. So, could you feed 8 people? Well, 7 people would get a full share, and then another person gets a half share. It could be, yeah, it could be. You just never know. So, we don't usually call people half peoples because that's, well, it's really mean, actually. So, I do not recommend doing that. Now, so what that means also, if you said, well, you could feed 7 people with full servings, okay, that's good. That's good. All right, 2 taxi companies. 2 taxi cab companies charge different rates for fares. Finish filling out the tables for each company. Explain how you got each amount of money for each table. Yeah, we'll give you guys a couple minutes to fill these ones out, okay? Take a look. See if you can figure out those missing values. I guess, a couple minutes go. All right, hopefully that's enough time for you guys. That's what I got right there. So Harmony is going to be, 6 miles is going to cost you 18, and then 927.15 is $45. Eureka though is 13.50 for 6 miles, 19.50 for 9 miles, and then I guess 31.50 for 15 miles. So now it does show for Eureka, right? Yeah, 1 mile is 3.50, but if that were the case, if this were consistent, then how much would 2 miles cost? Well, 2 times the 350 would be $7, right? But it's clearly not showing that. It's showing 550. So this will bring up the other questions that we're going to look at, right? Now this brings us to number 5. How are the two companies similar in their charges, and then how are they different? That's the real question we need to be asking up in here. So, take a minute and see if you guys can just write a sentence for both of these, and then see if you can explain it in a very precise way, okay? 1 minute, go. I know you guys got some questions about it. We're going to address it as we answer 5 and I think 6 as well. All right, hope you guys got something on this one. Let's look and see how the charges are similar and then also how they're different. Well, yeah, on the similarities, I guess, is they're both charging like unit rates, right? And we'll talk about what those unit rates are. Some kind of dollars per mile, I guess. So the similarities there. I'll say there is a rate, a charge per mile for both, I guess. Right now, are they the same charge? No, they're not, but they still are charging some number of dollars per mile. And yeah, we'll figure out what that is here in a second. So yeah, I like that one. Yeah, so yeah, they're charging well, I'll just say consistent rate per mile. Now again, we're not saying that they're charging the same amount per mile for sure, but it's definitely a consistent rate per mile there. Yeah, you're a little ahead of me on that one. Okay, so I'm not gonna wait on that. I'm not gonna write it down yet because it's coming, right? But I will write this. They definitely charge a different amount per mile. Okay, so I'll keep that one. All right, what is the rate per mile? And I know some of you guys have this figured out. That's okay. Again, this is called the unit rate, right? Rate per mile. You guys take a minute and see if you guys can solve that one, okay? All right, let's get started on these, you guys. And some of you guys have already mentioned that you know that they're charging the same amount per mile each mile, right? Which is good. That's important to know. They're just charging a different amount per mile for each company, right? So we got to figure out how much they're charging, their rate per mile for both companies there, okay? So it sounds like you've written the equation for it, which we're going to get into, if not in this lesson, a different one, okay? But that is very good, right? So here's how I would analyze and see, well, how much are they actually charging per mile? Well, you got to figure out how much they changed, and the nice thing about this table is it's actually showing changes in 1 mile, at least for these first 3 parts, right? There's another mile, there's add 1 mile, and there's another 1 mile, and there's another 1 mile. Well, how much did they charge each time? Well, it shows down here at the bottom that they added $3, right? Same right here, add $3. And then over here as well, add $3. Now, just to make sure it's consistent, we could continue this and say, well, this one added 2 miles, right? Well, if this were consistent and they're adding $3 for every mile, then this one should go up, yeah, $6. Okay, and then it works the same way. The next one was 3 miles, and then it shows a change of $9. And then the next one was 6 miles, which shows a change of $18. So it is consistent, at least for Harmony. We can see that they are charging $3 per mile. Now, you guys notice I put the slash there instead of actually writing the word per. Yep, I'm that lazy, man. Okay? So the next one, for Eureka, same idea. We don't really care about where they started, even though we may know that at least just like if you went 0 miles in the taxi cab, they'd still charge you $1.50, it looks like. And there are reasons for that. We're not going to get into that right now, but yeah, again, it shows, another 1 mile right there, and I'll do this one in red. Another 1 mile, and then another 1 mile. So again, we want to make sure that we're looking at consistency on this one. So from $3.50, if you add another mile, how much did they add in dollars? Well, it's $2 right there. So for the next mile, also $2. The next one, $2. Now, once again, just continuing the pattern, it shows the next one increased by 2 miles from 4 to 6. And when you went from 4 to 6 miles, they added, $4. Okay, so it's still a consistent pattern. It's just, and this is kind of the whole idea of this lesson, well, is it proportional? And that's what we're going to talk about here in just a second, okay? But yeah, for Eureka, they are charging $2 per mile. So even though they start out more expensive, very quickly they become the cheaper option. Put per mile on this one. Said, if we address what you're talking about here, just think about it like this. If I were to go back and say, well, you know what, let's take a mile off of this, right? Subtract a mile. Well, if you took a mile off, I'm looking at the 1 mile, right? So now I'm looking at 0 miles. Well, that means you'd have to take away $2, excuse me, $2 out of that. And then that means for 0 miles, they will charge you $1.50. So it's like, you know what, I'm going to call the cab, I'm going to get in. Oh, wait, I don't really need the cab. They're going to be like, well, then pay us $1.50 because I could have picked up someone else and taken them on a ride and then gotten money, but you wasted my time. So we're going to charge you $1.50. Now, there is a trade there, though, right? So Harmony is saying, you know what, we'll come by. We're not going to charge you an initial fee is really what that comes out to. But we're going to charge you more. Whereas Eureka says, we're going to charge you an initial fee, so use our service because we're also cheaper. You are right, though. 15 times the 2 would be that $30, and then it shows that difference of $1.50 on the 15 miles. And this one's only asking for the dollars per mile, and so $2 per mile. So it's just like what you're saying, right? Like if you wanted to say, I'm going to go for 4 miles. Okay, 4 miles, $2 per mile, that's $8, and then add that $1.50, so the total ends up being the $9.50. Okay. All right, graphing. We got to learn how to graph this business. Graph the cost for each company in 2 different colors. The independent variable should go on the x-axis is distance or cost the independent variable. We're going to get into that. Make sure to label the axis and include your scale for the axis. Okay, we'll go over this together. I just need the table. All right, so there's the table. In actuality, all I really need is the rate, right? I know that Eureka's charging $2 per mile, and then the other one, which I forget the name of, but it's on here. No, I didn't. Yeah, thank you, Harmony. Harmony is $3 per mile, right? So when you graph values, especially with word problems like this, and science stole it from us, so you think it's science, but it's really math, because child is actually this. Science is the child of math, which you need to understand. Science, for example, would never exist without math, which is fortunate for math people because it gives us, or makes us feel like we have lots of power. So we're comparing two things on this, by the way, right? We're comparing miles, and we're also comparing dollars, cost on this, okay? So those are the two things we're comparing, and we have the two axes on this, okay? And the horizontal one here, just in case you did not know, that's what we call the x-axis. The vertical one, the up and down one, that's our y-axis. So we do label these, generally speaking, but I got to put this one on manually. No problem, okay? Well, the x-axis is what we call the independent variable. Independent, like this, okay? And the y then is not independent, which means it's dependent. Dependent. And I could have spelled those wrong, but I don't care. So once we know that the x is independent, the y is dependent, then we can look at the two variables that we used and kind of ask ourselves, which of these depends on the other? Well, hopefully we know, just based on the taxi ride, right? How much you pay will depend on how many miles you travel in the cab. So that means that the dollars is dependent and the miles is independent. Dollars depends on miles. The cost depends on miles. So we can label the axis then, where the y-axis, right? That's dependent. So this is going to be cost in dollars, and the independent is how many miles traveled. Okay, and you can just put number of miles. That's okay. So now, after you label the axis, then the next thing you need to do is put a scale on there so that we know how much each line is worth. So on this one, I have to make this one a little bit smaller. I know miles, right? And you know what? I'm just going to say each of the lines represents 1 mile. So the big black lines, that's where 0 is going to be for both cost and miles. And then each of the lines will represent 1. So that'd be 1, 2, 3, 4, 5. Now you guys hopefully noticed I did not label all of those because I don't want to. Okay? And that's one of the whole points of math, is that we can simplify stuff. So that'd be 10, 11, 12, 13, 14, 15. Maybe this goes up to 20 miles. 1, 2, 3. Nope, not even quite. All right. Next up, we got lines for the y-axis. Now you may know, right, that you start at 150 for Eureka, but Harmony starts at 0. That's okay. But for me, I'm just going to say, you know what? I'm going to say that each of the lines represents 2, which means that right in between, and I don't know if you guys can see that, that'd be like $1. And so this one's $2, $4, $6, $8, $10 right there. That's a 0. 12, 14, 16, 18, 20 bucks. And then 22, 24, 26, 28, 30 bucks. We get to 40. 1, 2, 3. Yeah, we did. 40 right there. Okay. So 40, it goes all the way up to $40. And just remember, halfway between the lines is an individual dollar. So if you made your scale a little bit different, like going up by $1, it still doesn't matter. It's just your line may look a little bit steeper. Which also, I mean, since we're introducing this concept, like if you wanted to mess with people's brains, just by messing with the scale, and you're not even actually manipulating the data, which a lot of people do, which will be important for you guys to do as you grow older, but if you just change the scale, sometimes that really jacks with the line and how it looks, and then you could say, hey, look, I want you to think what I want you to think, and people are like, yeah, they're like zombies that way, okay? Because they'll be like, you know math? Oh, yeah. So let's start with Harmony, right? That was the top one up here. See if I can get it to go. There we go. Harmony is the top table, right? And, we know that for 1 mile, they were going to charge $2. Okay, so 1 mile, $2 right there. 2 miles was $4. No, it was 6, right? 369. Oh, $369, thank you. 1 mile was $3. I should have made that a little bit bigger for me. And then 2 miles was a 6. And then old niner. And again, I have to put these right in between there so that it gets those ones in the middle. So on this one, yeah, I'm going to go to the edge on this one just because I can. And so 9, and then it'd be $12 right there, and then 15er, and then 18, and then 21. Well, I went a little bit high on that one. 21 right there, and then 24, and then 27, and then 30, and 33. I know that not all these values were in the table, but I don't really give a crap because it looks so pretty. And so I got all these green lines. Now, another value we need to consider is, again, that zero value. Like, if you were to travel 0 miles in the cab, how much would it cost? Well, for Harmony, it would have costed that $0 right there. Okay, so I'm going to put that point in there. 0 miles will equal $0. You call the cab, and then you're like, you know what, I don't want to ride the cab, and then drive away, not charging no monies, okay? But what about Eureka? Well, we know, and we did this in the table, right? If we were to go 0 miles, they would have charged us $1.50, dude. Yeah, $1.50. And then they would have said, you know what, for each mile after that, it's going to be another $2, right? So let's go $2. And we can see just from what I got right here that the green dots and the orange dots are converging. They're coming closer together, and that's because Eureka is cheaper than the other one. In fact, I think I put that last one wrong. It was a $5.50, so it was $3.50, $5.50. Yeah, well, $5.50. So that's a $5.50. Yeah, I put that last one in the wrong spot there. It's already lower than that, right? I feel like I did that wrong. So that's it was $1.50. That's where I put this one in the wrong spot. $1.50 is about right there. And then the next one was $3.50. So yeah, I put this other one in the wrong spot. Dang it. So $3.50 would have been about right there, I guess. And then we can see already that the orange dots are already beneath the green ones, and that's okay. So $3.50, and then plus another $2. You know what I'm saying?
Can I just estimate?
Well, I kind of am because, you know, with decimals on graphs, yeah, you kind of have to estimate a little bit. But again, then these two lines are getting farther and farther away as we go up the graph. They're just not, they're going away, they're getting farther away from each other slowly, and that's okay. Well, is distance or cost the independent variable? We already know the distance, which was miles, is independent because the cost will depend on the number of miles. We labeled the axis and we included the scale for the axis. That's true. And the independent variable always goes on the x-axis. There we go. So this is the graph. Now, the next question, and I forget what it is. All right. How are the graphs alike and different? Well, they're both straight lines, at least. We know that for sure. They're both straight lines. And hopefully you're asking questions like in your brain, like, well, why are they straight lines? Well, we've already addressed that, just not directly as straight lines. These are straight lines because the rate of change is the same. So, for example, Harmony was charging $3 per mile consistently, and then Eureka was charging $2 per mile consistently, okay? So since it was consistent, we get straight lines out of this. So they are straight lines. However, how are they different? Well, the steepness is different. We'll address steepness in a later unit. But for now, we're just going to call it steepness. In the future, just understand this is coming, that we'll call it slope. Steepness is different, but not only the steepness, but how much they charge for $0 is different. Bam, there we go. I'll move this down so we can see that a little bit better. Okay, and that's the main thing we want to see. So yeah, this brings up the question, well, are they proportional? Well, if they were, then if we go back to the table, then the values as fractions would be equal, right? Now, that was true for the green one, which I think was harmony, right? Green was for harmony. And so that one was consistent, right? Like if you take the number of miles and divide it by the cost, you get the same value for each of those fractions. However, for Eureka, where they were charging the 150 at first, then theirs is not proportional, which we saw, right? Because 350 over 1 is not the same as 15 over 3150. Because they need to be equivalent fractions. Let me address that with more detail, right? So if I look at the green line, just going back to the table, I know I don't have it up here, but if we look at dollars, it was, for example, they showed $3 for 1 mile, right? And then when they showed 15 miles in the table, it was still, what was it, 45 bucks? Yeah, $45. Well, these are actually equivalent. These are equivalent. Since they are equivalent, we know that they're proportional. On the other hand, Eureka was showing that it was, what, $3.50 for 1 mile? For 1 mile. But then when we looked at the 15 miles, it was showing us $31.50. Well, are these two fractions equal? If you put them in the calculator, they're going to give you different decimals. So these are not equal, which makes it not proportional. So the orange one for Eureka, I believe it was, is not proportional. Now, that's how you tell with kind of like the pure math there we go. I got it. Proportional. But there's a very quick way to tell on a graph if relationship is proportional. All you got to do is look at the graph. Is it a straight line? Yes. If it's not a straight line, it cannot be proportional automatic. On the other hand, the other thing that must happen on the graph is it has to go through the origin, which is right where those two black lines meet, the x and y axis. So if it goes through that point in the middle, where the x and y axis meet, and it's a straight line, then it's automatically proportional. Which is why the green one is proportional. It's a straight line that goes through the origin. You have to remember that because you guys are going to be tested on it on the assignment as well. All right, here we go. Number 9, plant A is 18 inches tall after 1 week, 36 inches tall after 2 weeks, 56 inches tall after 3 weeks. Plant B is 18 inches tall after 1 week, 36 inches tall after 2 weeks, 54 inches tall after 3 weeks. Fill in the table with the data. Can you predict how tall each plant will be after 4 weeks? Well, let's find out. So I'm going to say this one is for, we'll say this is the table for plant A. And if they didn't put the table on your classwork there, that's okay. You just may have to copy it down, right? So we got plant A and plant B, and the two things we're comparing on this is number of weeks and then how tall it is, right? So I'll say this is its height. This is how many inches tall it is, right here. And then this will be the number of weeks on the bottom, right there. Okay, and I'll maintain consistency, so the plant B will also be inches tall. There's the top row, and then weeks will be this bottom row right here. Okay, so what did it say about plant A? Well, it said it's 18 inches tall after 1 week. So 1 week, 18 inches. Bam. Then 36 inches tall after 2 weeks. So, okay, 36 inches after 2 weeks. Now, if we were to compare these two, we can see that those two as fractions, if we had made these fractions like this, they are equal. So right now, that's a proportional relationship, but let's continue. It says it's 56 inches tall after 3 weeks, and 56 divided by 3, 1, and 26. Oh, that's not. Now, between these two, that is not equal any longer, which means it's not proportional. So when it asks here at the end, can you predict how tall each plant will be at 4 weeks? If we look at plant A, I don't know how tall this thing is going to be. Like it grew 18 inches the first week, and then another 18, but then suddenly it was 20. So that is inconsistent. Therefore, I wouldn't feel confident. Like, could I estimate it? Sure. But based on these values, I wouldn't feel too comfortable about my estimation, okay? Right, you could say, well, maybe it grows another 20, 21 inches. Okay, well, it depends on what plant it is, right? If they grow to a maximum height of 56, that'd be fine. But this is an inconsistent pattern, so it's not proportional, first of all, which does not allow us to make the prediction. So it is a little different than what we saw with Eureka, because Eureka, we know how much it started with, even though it wasn't proportional. We know how much it changed each time, which then allowed us to figure out how much they charged at the beginning. But this one, it would be difficult to say how tall it will be at 4 weeks. So, and there is that pattern right there. The problem with that is that, so, right, it shows that it went, or it grew 18 inches here and then 20 inches, so the next one would be 22. Part of the problem with that is that if we went 0 weeks, it would have went from 0 to 18, so that would have been, or we don't know, I guess. It would have grown 18 inches, 18, so 20, and then 22. It's like, yeah, maybe. But could it have been 20 as well? Perhaps. Maybe it goes up to every 2 phases, but we just don't know. There's not enough information to make this type of conclusion other than an estimation. Now be careful, because again, this type of estimation stuff happens all the time in real life, and people use it, and then they change people's minds on things, and it was false from the beginning, or there's not enough information to make claims like this. So let's look at plant B. It says, where is that? 18 inches in 1 week, right? So 1 week, 18 inches for plant B, 36 inches in week 2, and then 54 inches in week 3. All right, so again, this, we know 18 over 1 is equal to 36 over 2, but is that equal to 54 over 3? Yup! It's still showing that it's growing 18 inches every week, which means that for week 4, well, just to make this equivalent, because it is proportional right now, we'll say from 54 it's going to grow another 18 inches, which would then put us at 72 inches right there. So this is a pretty good accurate prediction. You know, again, it depends on the type of plant you're looking at and lots of other factors, but if we went straight off the math on this, we'd say, yeah, there's a consistent pattern, at least for the first 3. So for the 4th one, we should have a continued consistent pattern. And again, that all has to do with how proportional it is. All right, number 10, an elevator ascends at a rate of 750 foot per minute, in the table showing the height per minute. Okay, well, they told us the number of minutes on these ones, and we know it's 750 feet per minute. And maybe they should have specified that it would start at maybe 0. So I guess we get to start at 0, right? What I mean is, at 0 minutes, we'll say they're at a 0 height. Okay, so after 1 minute, bam, they should have gone up another 750 feet. Now, for this next minute, they're going to add another 750 to that, which appears to me to be 1,500. And then another minute, boom, should go up another 750 on this one as well, to make this 2,250. And then finally, this last minute, another 750 minutes. I get 3,000. Now, we don't have to label these in a table because the label is in the height over there on the left for the road. Now, another question they should ask on this, and I don't know if they do, and I don't really care, because I'm going to ask it, is this a proportional relationship? Yup, it is, because as fractions, these are all equal. And that's what a proportion is, where you have fractional values that are equal, minutes on the numerator and feet in the denominator. And again, if you found the decimal values for all 4 of these, they would all be equivalent. So what does it mean for something to be proportional? It means that as fractions, right, or rates, fractions or rates Fractions or rates are equal. Now you could say equivalent, and that's a little bit more technical than I want to be right now. That'd be okay. And that's for fractions, right? Now on a graph, though, it's a little bit different, just like we talked about. I mean, as fractions, they would be equal, or rates, they're equal. But we're going to specify this. It's a straight line that goes through the origin. Okay? And then there'll be a way to identify that in equations, but for now we're just looking at it as fractions. So equations, fractions, or equations, graphs, and tables. We've already seen the tables. Again, we just make the values fractions and then compare them. Which of the above situations do you think are proportional? The elevator example, the Harmony Taxi Cab Company, all the pizza examples we assumed were proportional as well. That's why we solved them with proportions. All right, here's our objective. I can determine when situations are proportional. All right, Sop, if you have not done so yet, let the students grab a computer. They should be able to start on the assignment. Just make sure, about with 10 minutes left, you guys need to put those calculators and computers back and pick up the floor around your desk, okay? Sorry I'm gone, but I will see you guys on Monday. Well, Tuesday, I guess, for you guys.